Hello. Now we'll study about the electric field. Since we already know that electric field for all inside points is 0. So for all inside point of this conductor, electric field is 0. Obviously after achieving the equilibrium state, whatever properties we are talking about only after achieving the equilibrium state. Now we want to see, because of this conductor, what will be the electric field outside, or I'll say just outside, meaning for these points. Okay. So let's talk about 2 points. I'm taking this A and this point is B. So I'm taking 2 points onto the surface of this conductor, A and B. One thing about these 2 points, the potential at A and the potential at B will be same. Why it will be same? Because we know that. And at the same time, in case of conductor, any point onto the conductor they are going to have the same potential. So both of these points are going to have the same potential. Not just these 2 points. All the points onto the surface, they are going to have the same potential because it is a conductor. So it's an equipotential surface. The outer surface of this conductor is an equipotential surface. And regarding equipotential surface, we know that electric field is always perpendicular to the equipotential surface. So if there will be any electric field outside, okay, there are 2 cases. There might not be electric field, there might be electric field. So if there is going to be any electric field just outside to this conductor, that electric field will always be perpendicular to the surface. Okay, so either the electric field will be 0 if there is no electric field, but if there will be electric field, it will always be perpendicular to the surface, always, because the outer surface of this conductor is nothing but the equipotential surface. This surface is equipotential surface. Equipotential surface. So since it is an equipotential surface, all the electric field will always be perpendicular. There can be 2 cases, meaning if there is, let's say, some external field is there. So if there will be some external field, if I'm having this conductor and if I place this conductor in some external, when the external electric field is non-zero. So if I place the conductor in an external electric field, then what will happen? Because of this external electric field, the redistribution of charge inside the conductor will take place. So in the beginning, inside as well as outside, electric field will be only E external. But the moment you put this conductor in this external electric field, the redistribution of charge will be happening. This is before redistribution. This is before redistribution. And then, if you see after redistribution, there will be some different case scenario. After redistribution, you will see outside obviously there will be some electric field, but the nature will change, because you see, because of the redistribution of charge, some charge will come. Like positive will go here, negative will come here. This is a redistribution of charge happening, so we'll call it polarization. There is no extra charge, I'm putting it here. So because of this, for inside points, the E net, for all inside points, the E net, which is a combination of E external plus E internal, that will become 0. So E net becomes 0. I'm not saying E in becomes 0. This is not the field due to the inside charge. This is the net field due to the all charge. Since there was no electric field I have shown, so if inside is 0, external is already 0, so it will become 0. So E net electric field for all inside points will become 0. So this field will make external field 0 for all inside point. But the thing is, this E in, because this E in is coming because of this redistribution of charges. And since this redistribution of charges are happening, this structure looks like a dipole. So this structure will also have its own electric field. That own electric field is nullifying the electric field inside the conductor. But this own electric field will also change the field outside the conductor also. I said change, I didn't say nullify. Inside it will nullify, but outside it will change. So what will happen? The net electric field, if you see at the surface, at each and every surface, net electric field will be perpendicular. This is the net. So this field is coming because of the resultant of this and the resultant of internal one. So if you are having a conductor if you are having a conductor, whether you put this conductor in a non-zero electric field, or you put this conductor in a variable electric field, or you put this conductor in no field, one thing is sure, inside you are not going to find any electric field. If outside was, if there is no electric field, then inside will not get developed. And if there is some external field there, if you are going to put this conductor in a non-zero electric field, then this conductor will become a dipole because of redistribution of charges. Negative will go there, positive will come here. Then this will become as a dipole. And why it is becoming as a dipole? Because this conductor cannot have any electric field inside. But at the same time, if there will be field outside, at the surface, field will, at each and every point at the surface, field will become perpendicular. At some point it might be going inside, at some point it might be going outside. Inside, outside is possible. In this case I have shown all outside, it's not the case. At some point it might go inside, like in this case it will be going inside. Here it will be going inside. Here it will be coming outside. Like that. Okay, but each and every point, the field, net field is going to be perpendicular to the surface. And I'm talking about the net field. So E net is going to be perpendicular to the surface of conductor. And when we talk about E net, we mean E external. This E external can be constant, it might be variable also. Plus internal because internal charges, that electric field we are talking about. Okay, so I hope you understood this property. Thank you.